6.4, completing the square. Okay, the goal is to understand how to solve quadratic equations with this new method called completing the square. So above quadratic, let's write, hopefully you got it memorized, that's just a x squared, something to the second power. And there is always going to be two roots, or two solutions. So the method we're going to use is completing the square. And to be good at this, you really have to be pretty savvy on your squares. So before we get started, let's polish up. Number one, the quantity r plus 1 squared, you are going to take the quantity r plus 1 and times it by itself. So rewrite it so it looks like that, and then just do the distributive property and multiply through. R times r is going to be r squared. R times 1 is r. And then 1 times r is r, and 1 times 1 is 1. So your answer is going to be r squared plus 2r plus 1. Okay, so go ahead and jump up to the board, stop it, and give you guys like 5 minutes to do 1 through 10. And you do a few of them, there's going to be a pattern that you should stumble on. So go ahead and hop up and pause it, and then resume it, and we'll check your answers. Alright, so let's check your answers. Number 2, you should have x squared plus 10x plus 25. And then number 3, you should have 1 minus 10m plus 25m squared. Number 4, n squared plus 8n plus 16. Number 5, 1 minus 16v plus 64v squared. Number 6, n minus 16, n squared. N squared minus 16n plus 64. So 1 through 6 is where the pattern hops out. Look at number 2. This middle term, 10, comes from adding your two like terms in the middle. So if you're going to have a 5 times x, you're going to have a 5x and a 5x. That's 10x. And then the last term comes from 5 squared. So look at number 7. My first term is going to be 6a times 6a. So it's going to be 36a squared. My middle term is the hard one. The last one comes from your last term times itself, 7 times 7. So the last term is 49. The middle one, you actually take 6 times 7, and that's 42, and then you add it to another 42, so you're going to have 84 a's. So let's try it for 8. 8, the first term is going to be 2 times 2, so that's 4. Your middle term is going to be 4 times 2, that's 8. Add another 8, so you're going to have 16 k's. And then plus 16k squared. Number 9, 36x squared. Let's see, it's going to be a minus 12x and plus 1. Number 10, you're going to have 25x squared minus 30x plus 9. Okay, now let's go backwards. Let's practice some more. Let's factor them. So number 11, this is a trinomial. It's an addition problem. You need to factor. Rewrite it as a multiplication problem. So it's going to be a quantity times a quantity. And to get the first term, that's pretty slick. It's just going to be n times n. To get the last term, oh, that's easy because that's only one choice. It's got to be plus 1 plus 1. These are all going to be squares. So you can rewrite it as n plus 1, the quantity squared. So same thing, hop up, pause the board, give yourselves 5 minutes to check them through, and then resume and we'll check them. Problem 12, you should have n plus 2, the quantity squared. 13 is p plus 4, quantity squared. 14 is n minus 3 quantity squared. 15 is x minus 5 quantity squared. 16 b minus 2 quantity squared. Okay, 17, 18, 19, 20. These ones are a little more complex because the coefficient of the quadratic is not a 1, but they are all perfect squares. So 17 is going to be 3r plus 1 to the second power. 18 is going to be the quantity 3x plus 2 squared. 19 is going to be the quantity 4m plus 3 squared. 20 is going to be 3a minus 5 squared. Alright, so let's put them to use. Now there's two methods we're going to learn. The first one is the square root property. And remember, you're always going to have two roots. And when would you use this? Let's write this down, this bottom answer. When would you use this? You're going to use this when your roots aren't going to be in the set of integers. So your roots are going to begin to become irrational numbers and even imaginary numbers. So when your roots are not going to be integers, these methods come in handy. Let's look at this guy right here, for example. So the method that you know is to get everything on the same side. So if you minus 7 minus 7, you're going to have x squared plus 8x. 16 minus 7. Oh shoot, never mind, this might be a bad example. Is 9 equals 0. I think this one will factor. So if you do factor it, so you get everything on the same side, now you factor it. So it's going to be, if you factor that, what is it going to be? X plus 9 times the quantity x plus 1 equals 0. And then you use your zero product property. So if you're multiplying and your answer is 0, either the first quantity was 0, so that would mean x would have to be a negative 9, or the second quantity is 0 and x would have to be a negative 1. So I lied. Those answers are in the set of integers, so we're okay. So I need to find an example where your problems are not in the set of integers. I wonder if this guy right here is going to give us, I think it is. So look at this one. Let me erase all this. If you look at this guy right here, if you minus 8 minus 8, you're going to have x squared minus 6x plus 1 equals 0. Alright, now if you try and factor this, if you try and write this trinomial as a quantity times a quantity equals 0, x squared, that's going to be x times x. What two numbers times and give you 1, but then add and give you a minus 6? And that's where we're going to come into trouble. So if you recognize that your answers are not going to be in the set of integers, this method right here, the square root property, can come in handy. So today's whole lesson is on squares. So look at this right here. If you see this and you think to yourself, oh, that's a perfect square, x squared minus 6x plus 9, if you rewrite this as a perfect square, it would look like the quantity x minus 3 squared, and that's equal to 8. So this is when you would use this method. If you recognize right off the bat that there is a square, and all four of these examples are perfect squares right off the bat. So instead of moving everything to the same side, if I rewrite this as a square and set it equal to 8, now I can solve it. So solve for x. How do you undo a square? You take the square root. So if you take the square root of the left, square root of the right, you are going to have on the left just x minus 3, and on the right, here's what you have to remember. If you take the square root of 8, there's actually two answers. There's the positive root and there's the negative root. And this is where our two answers are going to come from. So let's take plus or minus square root of 8. But then from our skills in chapter 5, you cannot leave the square root of 8 as it is. You need to simplify it. Square root of 8, let me come up here. X minus 3 equals plus or minus square root of 8. Can be rewritten as x minus 3 equals plus or minus square root of 4 times the square root of 2. So you need to simplify your radical. Square root of 4 is a whole number. So x minus 3 equals plus or minus 2 times the square root of 2. Okay, now just solve for x. Get x alone. You're going to add 3 to the left, and you're going to add 3 to the right. But you need to add 3 to 3 plus or minus 2 times the square root of 2 is going to be your final answer. Or you could do 3 plus 2 times the square root of 2. So you add it to the positive root of 2 times the square root of 2. Or you add it to the negative root of 2 times the square root of 2. But instead of writing it out as two expressions like that, you can just write the plus or minus symbol, and it's a little bit slicker. Okay, so let's just do one more. This is an example where your roots are not in the set of integers. These are in the set of irrational numbers. So this is where this comes in handy. Before we move on, let's look at this guy right here. Okay, x squared minus 10x plus 25 is equal to 49. So try using the square root property. Recognize that on the left, that's a perfect square. So move number 1, rewrite that. Rewrite it as the quantity x minus 5 squared, and that's equal to 49. Okay, now solve for x. So undo the square. Square root on the left, square root the right. On the left you're going to have x minus 5. On the right, that's awesome because square root of 49 is a whole number. But remember to take both roots. It's going to be plus or minus 7. Now get x all by itself. Add 5 to the left, add 5 to the right. So if you do 5 plus 7 and 5 minus 7, you're going to get 12 or a negative 2. And those are your two roots, 12 or a negative 2. Okay, now let's talk about completing the square. Method number 2 is called completing the square, and this is going to come in handy later on when we do circles. So this is definitely a good thing to know. Here's your instructions. Find the value of c that makes this trinomial a perfect square, and then write the trinomial as a perfect square. So you've got x squared plus 16x plus question mark. They want you to force this to be a perfect square. So why don't you pause it and take a few minutes, see if you can just figure out what value you could plug in for c that would complete the square or make that a perfect square. Pause it for a few minutes and then jump up and hit play. Alright. If you chose 64 for c, that's correct. This one, x squared minus 18x plus c, the c would be 81. And minus 12x plus c, the c would be 36. And this last one's kind of tricky. It's going to be 12 and a quarter, 12.25. And then if you rewrite them as a perfect square, it's going to be x plus 8 squared, x minus 9 squared, x minus 6 squared, x plus 3.5 squared. So let's explain how to do this. Here's what we're doing. Here's how we got 64, 81, 36. It's all back to the pattern that we hopefully discovered. So your quadratic equation in general form is ax squared plus bx plus c. This is the general form of a quadratic equation. or a quadratic expression. So here's what you do. Step number one, let's just write this as steps. There's only two steps. Step number one is divide b by 2, or cut it in half. So in this case right here, let's call this number 1. The b is 16, the a is 1, and the c is what we're actually trying to find. So the b is 16. If I take 16 and I divide it by 2, I get 8. Alright, step number 2, square that number. So 8 is my number. I'm going to square it. 8 squared is equal to 64. And that is my C. So this one right here, 18 divided by 2 is 9. 9 squared is 81. Number 3, 12 divided by 2 is 6. 6 squared is 36. And number 4, 7 divided by 2 is 3.5. Square that and you get 12.25. And then write them as squares as we did earlier. So completing the square is pretty slick. Now let's use it to solve an equation. Okay, your equation. Let's get some steps before we tackle this. Number 1. Step number 1. Get ax squared plus bx all alone. So get it all by itself. So let's go up here. Let's call this number 1. You are going to follow step number 1. Get x squared plus bx all alone. So you're going to minus 6 minus 6. That's move 1. So you got x squared plus 8x equals a negative 12. Okay, move number 2 is what we just barely did. You're going to complete the square. Complete the square. And if you don't remember how to complete the square, go to this slide right here. It's only 2 steps. Take b, cut it in half, and square it. So b is this is my b right here. B is 8. So if I cut b in half, that's 4, and I square it, that's 16. So I am going to force this on the left hand side. I'm going to force it to be a perfect square by adding 16. And since it's an equation, if I add 16 to the left, I have to add 16 to the right. Okay, now step number 3. Rewrite it as a perfect square. So rewrite as a perfect square. So here's step number 3. X squared plus 8x plus 16 is going to be x plus 4, the quantity squared. On the left, a negative 12 and a 16 is equal to 4. Okay, now just solve it. So undo the square. Square root on the left, square root on the right. On the left, I've got x plus 4. On the right, I have a plus or minus 2. So now I've got a minus 4 to both sides. And I'm going to have the plus 2 minus 4, and I'm going to have the minus 2 minus 4. So my two answers are going to be a negative 2 or a negative 6. So again, both of those roots were integers. They're in the set of integers, so easy to work with. We love them. But let's do one where they are not going to be in the integers. Let's do, let me erase this. I'm not sure which one of these are going to end up not in the integers. Let's try let's try this one right here. Let's see what this does. N squared minus 6n plus 52 equals a negative 10. So if your instructions say complete the square, factor it by completing the square. Step number 1, get ax squared plus bx all alone. So I'm going to minus 52, minus 52. So I've got n squared minus 6n equals a negative 62. Alright, now step number 2, complete the square. I've got the makings right here on the left of a perfect square. I'm going to manipulate it and turn it into a perfect square. So I take b, cut it in half, that's 6, cut in half is 3, and square it, that's 9. So if I add 9 to the left and I add 9 to the right, I am going to get this equation. N squared minus 6n plus 9 equals a negative, what is that, 53? Okay. Now, rewrite it as a perfect square. So I recognize this is a perfect square because I forced it to be one. So I'm going to go n minus 3, the quantity squared, equals a negative 53. Alright, this is going to be a good one. So now if I just solve the equation, I got to undo the square. So I square root the left, square root the right, and I'm going to have on the left n minus 3, and on the right a square root of a negative 53. Okay, now if you remember, square root of a negative anything is an impossible feat to try. So now we're leaving the set of real numbers and we're going to play around in the set of imaginary numbers. So let me erase some of this stuff. So from here I am going to write this as n minus 3 equals square root of a negative 1 times square root of 53. And square root of a negative 1 is your imaginary number. So I'm going to change that to I times the square root of 53. But remember, there's going to be two roots. There's going to be the positive root or the minus root, plus or minus. So now, if I add 3 to both sides, here's what I'm going to end up with. I'm going to end up with n equals 3 plus or minus the square root of 53 I. So your answer is expressed as an imaginary number, a complex number. 3 plus the square root of 53i, or 3 minus the square root of 53 times I. Alright, so your homework. Why don't you guys start playing around and do side A. Get side A. Side A is going to be due the next time we meet. If you have time, go ahead and start on side B. But we will review some more on Tuesday in class and finish side B then. So for homework, what is due the next time we meet is side A. So you guys work through it, play together, and enjoy your squares.